straight out of Colorado, Hunter Beast. And he'll be talking about how as you can see, how RGB colors coins in secret. Hunter delves into Rust, Bitcoin, furries, and the Lightning Network. He builds privacy-focused, self-sovereign products for creators and their fans using Bitcoin native technology that need no blockchain or token to use other than just Bitcoin. You can find him at cryptoquick.substack.com, and his GitHub is cryptoquick. Take it away, Hunter.
Yeah, hi. Oh yeah. Cool. Can you hear me now? All right, cool. Yeah. So one thing that you might kind of wonder about the title of this presentation is like, what is a colored coin? That's essentially an alternate unit of account. Some people know that as a token, and some people don't know this, but it's one of the original token implementations from 2013 or so was something that Jimmy Song worked on, and some other people. Actually, I don't know if Jimmy Song worked on OmniLayer, but OmniLayer was one of the originals, and that was used for issuing Tether on. And Tether is now officially, just as of last week, discontinuing OmniLayer, but it had a pretty good run, like 10 years. And it's now being discontinued in favor of RGB as RGB is maturing, which is really good news in some ways. Jimmy Song, he reflected on like why colored coins didn't quite take off, and there was just kind of concerns around lack of standardization, and that was something that the LNPBP Foundation was founded to hopefully get around. Marketing, I mean, if you pre-mined 72 million ETH, you have a hell of a marketing budget, I guess, to really push you can create a market, and then so people didn't really like have an idea of what to do with tokens at the time, but then all that happened, and so why are colored coins kind of, or at least tokens, why is it useful or good to have alternate unit of account on Bitcoin? Well, there's a market for it, and there's just a bunch of people who want to do it. And what I want to do is minimize the impact to the time chain. And so one thing that RGB does is it's very scalable and it's very private. And so I hope that maybe by the end of this presentation you have a sense for the scalability characteristics of RGB and why it essentially could really dramatically reduce the current demand for the UTXO set and for block space, or at least help scale that demand in some way. RGB. So RGB is it came about in I think maybe 2017, 2018. It started people started talking about it back then, and then it started getting more development energy in maybe 2020 or so, and it's essentially it doesn't just do tokens. It's generalized contracts in general. It keeps the contract data itself off chain, so it's not there's very little, there's nothing on chain that can identify that this is a contract if it's using Taproot, and so and contract execution has a VM, and it has bytecode for the contract, and this happens in this gets run in clients, and client would be a wallet. And imagine if we took all of the smart contracting capabilities out of, say, what's capable of happening in an Ethereum node or an OmniLayer index, and instead put it in the wallet itself. And imagine like how complicated that could be, and that's something we've accomplished. And one thing that's interesting is if so contract state is sharded, and so what that means is that if Alice issues 100 RGB coins to herself, and she sends 50 to Bob and 20 to Carol, Bob can't know Carol's balance or allocation, and vice versa, and that's because they have different contract data. And the double spend is prevented using essentially and I'll go into that. But because the contract data is kept off chain, it has really good privacy characteristics, because like you can't see into it if it's not there. Like if it's not available for everyone to see on a block explorer and either scan or what mempool that space, if it's not there, you can't. Not only can you not like observe or introspect or surveil, right? But you also can't manipulate. And so one thing that a lot of people are concerned about is MEV. In some of these DeFi markets, MEV being a miner extractable value, these miners will essentially rearrange transactions so that privileged actors can go in and front run certain trades for liquidity, to like slice off a bit of each swap essentially, and it's essentially like an extra fee on top of the gas fee. And so in a way it's extractive out of this market, and it's largely a consequence of the fact that people can see into this transparent DeFi activity, and then they can manipulate it. Whereas if it's entirely private, well, privacy is like the cure to MEV. And one thing I just got to like really be clear about is that this is Bitcoin only. There's no other blockchain, sidechain, or whatever, and there's no fee token involved. It's just other than sats. So RGB 20 is a specification that has two kinds of state. All contracts have two kinds of state. They have global state and owned state. Global state is sort of shared and immutable, and it's part of every contract. And then the owned state is what's kind of sharded, and it's kind of what goes into each individual's allocation, and it's more mutable. And that goes against what's called a seal, and it's basically against a UTXO on chain. And so a UTXO proves three things: that it has an owner, that it is currently unspent, right? Like if it's an UTXO, that means it's unspent, and that also means that it hasn't been double spent, because and those are like all significant things for securing sort of monetary systems. And so we get to benefit from Bitcoin's design and its security. This is going to be really tiny for you guys. I'm not going to go into it. Also, it's Contractum's neat, but it's also still in development phase. But like it's just kind of to illustrate, the different properties of a contract interface, and then the methods and that can be called on it. But that then compiles to ALUVM interface bytecode. But what's interesting about that is since Contractum isn't yet really ready, we just this is written by hand. This is a format called ASCII armored base 85. So speaking of LUVM, it is a VM execution layer, and it can compile to WASM, which is neat, and it's very minimal and very optimal, and it's perfect for our needs. Just kind of to tie this all together, interfaces define, what a construct can do, whereas schemas define how that occurs, what exactly goes into, say, subtracting or adding, to someone's token allocation versus like, transfer will do that, and then the interface specification will be defined in contractum, but currently it's defined in LUVM by code, and also schemas in LUVM. And then interface implementations are then in Rust, which would then be cross-compiled to like WebAssembly and then called in by JavaScript or whatever you want to use it. And these are then called within the wallet itself. And so these are all just kind of like go into a library. And so it's different than, say if you're familiar with the Web3 Ethereum like RPC node, where you're just like, you'll have like this like, you'll have like kind of like a ABI, and you'll try to like sign messages for that ABI, and that you'll have some of that in your client itself, but you'll also have, it's kind of like that, but everything's more built into the wallet itself. And the reason why we have, a separation between schema and interface is just, so that we have a good, solid design principles. And the thing to understand about RGB is that it's based on client-side validation. It's like all this occurs in the client, in the wallet, and it has to be very deterministic, very repeatable, very verifiable. And in order to do that, you need a very rigorous attention paid towards how you serialize and handle data types. Because if you go to, serialize something, then deserialize it, make some modifications, and serialize it again, you want to make sure the parts that you haven't touched, like that you haven't modified, still serialize in the same way, so that it's it's a repeatable way. And that sometimes is a nuance that doesn't always carry over on every platform and every instance. It's just in practice, and so we had to be very careful about how that was designed, the reason why is because that could break consensus, and this is like an off-chain consensus amongst contract holders and people using transferring and that sort of thing, and it generates this like semantic ID, which is like right here, like there's this like Saturn Flash Emerald at the end there. It's like this like kind of mnemonic, at least at the end of the semantic ID. You can kind of visually identify whether it's changed or not. And this is like kind of like essentially a hash of the file's data structure, or like all the data structure like of what you just serialized. And that's really important for the next slide, which is where we keep track of how like the different libraries, how they like for the different schemas and different contract interfaces and things like that. If those ever change, we actually have like an automated generated file that helps us keep track of what version of our library corresponds to the libraries that are in use at the time. And in addition, that hash, that semantic ID is used to create a 32-byte hash of contract state. and that's for a deterministic Bitcoin commitment. And so this is essentially for like kind of like the very very it's a hash of like the of the contract of a single contract state as it currently is supposed to be within that block, say. And what's interesting though is that you can include multiple of these deterministic Bitcoin commitments within what's called a multi-protocol commitment using tap trees, using essentially Taproot, because you have these. So the semantic idea is or the DBC, the deterministic Bitcoin commitment, is an opereturn, and it gets hashed into the mast tree, and then the tap tree, which is called mast. It's a Merkleized AST abstract syntax tree, and it then kind of like each hash builds on each other up until the Merkle root, and then that Merkle root becomes an X-only public key that's put into a pay to Taproot address, and then that's what's used to transfer whenever you go to transfer or change state of any kind. And this commitment can commit to over 250,000 different contracts onto a single 32-byte hash, and there's all these just different like DBCs in this multi-protocol commitment, and all these tap leafs and all these nodes, and you can provably you can prove that these are unique within that tap tree as well. That's an important key aspect of this, and there's some good descriptions of this in the RGB black paper and also in the LNPBP's specs. So to kind of make this feel more real, we in the Bitmask wallet, we have this a function where we go and fund what we call like a tokens vault, and we create this transaction where it gives the user 4 dust UTXOs, and they have 2 dust UTXOs for RGB20 and 2 dust UTXOs for RGB21. And the first dust UTXO is used for receiving tokens, and the second one is used for change. And so when you spend, one UTXO, you spend all the contracts from it. You'll take the contracts that you don't spend to someone else. You send them back to your change UTXO, and in the same transaction, you'll create a new dust UTXO. And this is an example RGB transfer transaction. In this one, you're essentially creating a new dust UTXO. This is on the lower right here. I don't know if you can see, but it's basically this is actually like a really boring transaction, but because it really does look like just a ordinary Taproot payment. Like there's nothing really even in the witness that's distinct from a Taproot payment. So this is good for censorship resistance. There was, some concerns about, like, should we censor ordinals? Well, if you want, you can, because, we have RGB now. And so that's what the degens can use if they want. But that also, what's nice is that if we're able to put, hundreds of thousands of different contracts onto a single UTXO, then, like Jameson Lopp earlier was, made the observation that ordinals inscriptions, they just leave these UTXOs hanging out in the UTXO set, and there's probably, I think, 11 or 13 million additional UTXOs being ascribed to the ordinals usage since it first came out, or just grew popular around April or February this year. And the thing is, if you're able to kind of consolidate that usage into of those distinct tokens into a single UTXO, or at least a good amount, you can reuse all of that. That could not only could that significantly at least reduce, hopefully the impact as demand for that scales, but also it just helps scale the the market for that in general. So just like obviously there are limits with Bitcoin in general, and so there are always going to be real costs, and the market will do with that what it will. But if we offer a solution that offers privacy and lower costs and more scalability, the assumption is that people will want to, as will gravitate more towards that over time. This is a screenshot of one of our BitMask wallet. It's a web wallet and browser extension, and we have created a coin, like a token over here called Nobi, and we're transferring it from wallet 1 to wallet 2, and we minted in the mint operation 21 million Nobi, and 100,000 were transferred over to this other wallet on testnet, and it just creates a transaction that's very similar to this one. Yeah. So the developer ecosystem is we have like BitMask Core is part of what we use. It's a web based JavaScript thing. It's good for also stateless backend services, whereas RGB tools is more for say server or like kind of self-hosted node, like a Android or mobile devices. It's good for that. Here's some more resources to learn about RGB. I have these slides shared on these social links as well, so that you can just go ahead and go to a link on the slides and get the slides if you want to review some of that information and connect with me. I've got a Nostr pin up here, so if you just want to go and tap my pin, you can go and get to my profile. So yeah, that's it.
Thanks,